Hello and welcome all. I, Prathamesh Brahmankar, welcome you all to this panel discussion with our grooming CEOs of Rohan Ganapathy and Sunny Kabrawala with the host for today's evening, Mr. Naman Bajaj. Space is vast, flying is diverse, and exploration is mesmerizing. With billions of galaxies and stars and planets in our own solar system, yet to be fully explored or understood, scientists' knowledge of space is always evolving. We know only a tiny fraction of our universe, and the quest is to know more. The theme for this lecture or the theme for this session is to explore above and beyond, a dive into space travel, through which we aim to educate, inspire, and incline young minds with ideas of innovation and inspiration to tap the untapped potential in the scientific field of space travel. With us today, we have a dynamic duo of speakers to dig deeper into the fascinating world that lies above us. This brings me to the introduction of the speakers for today, Mr. Rohan Ganapathy and Mr. Sunny Kabrawala. Mr. Rohan Ganapathy. He earned his degree in aerospace, aeronautical and astronautical engineering from the Hindustan College of Engineering and Technology in 2014. His area of specialization is spacecraft propulsion, rocket engineering, electrothermal propulsion, and orbital mechanics. He also takes interest in heliophysics and deep sky observation. He was the principal investigator for the development of India's first microwave induct induced electromagnetic thruster, which support USW still. This year, after his graduation, he started a private aerospace manufacturer and small satellite company headquartered in Bangalore, India, named Bellatrix Aerospace Private Limited. The company plans to launch its own rocket named Chetak. He in Bellatrix Aerospace is involved in the development of liquid propellant rocket engines and in-space propulsion systems. So this was just a short introduction of Mr. Rohan Ganapathy. Mr. Shani Kabrawala. He is the founder and CEO of Star Labs, based in Surat. He is an electronics engineer, young entrepreneur, researcher, space enthusiast, and a TEDx speaker. Since his childhood, he has been passionate about space research. He has done his internship at Technical University of Sofia in Bulgaria. He was a part of a space camp that was held in Bangalore in 2014. He worked as a project head and was a core member at Space Development Nexus. He was also a part of the executive committee at Mars Summit in 2017. He has been invited by many schools, colleges, and organizations and technical festivals like us to conduct an expert lecture on modern rocketry. He was a student ambassador of Google powered startup Weekend Surat. He was invited as a speaker at TEDx Surat to deliver a talk on how to build a rocket in $100. Yeah, it's amazing. So this brings us to the end of the introduction of both the speakers. And now I would like to hand over the session to Mr. Naman Bajaj without any further ado.
Thank you, Prathamesh. Thank you for such a wonderful introduction of our guests for tonight. First of all, I would like to begin the session by asking a very basic question. What, according to you, is space? That is, if you were to define space, how would you do that in your perspective of space technology-based startups? Rohan, would you like to go first?
You want to start with me? Okay. Hello, everyone. Nice to be amongst you this evening. And going back to Naman's question, space, according to me, is just another adventure land, I would say, but not in the comic sense, in a very serious way. If you look at our ancestors, I mean, not our grandfathers, the real ancestors, they all moved from one place to another. So, in the name of exploration and settling down, right? And the Earth was a big place back then. So that's how we, humans conquered the entire planet. Similarly, it's in our genes to actually go out and explore. So now the planet has become a very small space for us, in terms of travel and connectivity. So space is the next big final. I mean, it's the final frontier. But to start with, it's so big and so vast. Actually, we should set our eyes out there. It's in our genes, and let's go on this big adventure, and that's space.
That's really wonderful, Rohan. Sunny?
I think, like first of all, thank you so much for the wonderful introduction, and I completely agree with Rohan. Like space is full of adventure, and like we know that space, like exploring space, is no different than exploring about ourselves. We just get to know about how everything got into existence, and how can and there's a lot of opportunity out there actually in space where still a lot of exploration have to be done. We have to figure out what things exist there, how can we use it, so that because earth have limited resources and the way we are using limited this resources, I think if we don't do anything, earth would become next Mars, that is dead planet. So we have to figure out how can we get the resources out there from space, and then how can we use it. So that is like space is a place where a lot of innovation is possible nowadays, and just it's the next opportunity for the upcoming generation.
Nice. Interesting. Now, when we talk about space in India, the one thing that comes to our mind is ISRO. And as we know it, the goals and vision of ISRO is to help the society by using space technology. They have had very few satellite launches which aim to explore the nearby planets or the universe as a whole. This is something NASA does quite frequently with the help of JPL, the Jet Propulsion Laboratory. So, to which field or fields exactly do Bellatrix and Starlab plan to contribute? Sunny, would you like to go first?
Definitely. See, ISRO is operating into a very different environment than NASA, and I say this very often. It's very it's not so good to compare two different companies operating in two different environment. And the second thing, if you talk about the budget of ISRO, it's very less, and the vision with which it got started was to serve common people, right? So ISRO have been in no competition with others in the terms of space application so far. We have been serving and helping people out there, common people. Now, if we talk about STAR, we have a very clear vision of providing the access to space to the students community. We really see a future where students would be able to send their experiments out there and would be able to get them the experiments back, that is through sounding rockets, and so that we don't create any junk out there. And if they want to experiment again, they don't need to build the whole satellite again. They can just modify, and they can relaunch it. So that is a future that we see, and also providing some limited access to the interplanetary missions as well. So that's the far side vision that we're holding right now.
So the student-based satellites, they can be anything with applications from agriculture to astronomy.
It can be anything. Like nowadays, there are a lot of experiments being designed based on astrobiology as well. I see some small scale telescopes are being, designed by the students. But the problem here is we don't have a very quick access to space. And when we say quick access to space, I don't mean the orbital launches. I mean the suborbital flights in India. So that is one target that we are having right now.
Okay. Rohan?
Again, I agree with Sunny. ISRO was not started. For the claiming to the world that we are a superior country. So Vikram Sarabhai's vision was crystal clear. That is how to see space as a means to enable common good for common man on earth. It was a very good vision. Back then, a country like India with very limited budget was able to do. But of course, ISRO did achieve that feat, and now they are also looking at future R&D, as I would say, because satellites and rockets are something these days private industry is capable of taking up. So ISRO has the role of now developing future tech, same thing as NASA. So at Bellatrix, again, just a correction to what introduction Prathamesh made, we are no longer pursuing Chetak as a launch vehicle. We are a core and core space propulsion systems company. So we develop electric and chemical propulsion for in-space travel or in-space maneuverability. So that's what we do. And I always give this example. Gold is available underneath the ocean bed, but why don't we mine it? Is because the cost of mining is more than the value of gold. It doesn't make sense. Similarly, if you asteroid mining or lunar mining and all is no longer science fiction, but still it's so expensive because the transportation accounts to 90% of thing. Lifting such a heavy weight, going there and bringing back doesn't make sense. So technologies like ours, where we use water as a propellant and all, they are so efficient that they can cut down the transportation part of it. So that's where we tend to see ourselves. You can call us Ola Uber of space. That's where we are actually focusing on that. Space transportation company is a better terminology now.
That's a good analogy that you have there, the Ola Uber of space. So, by how much percent, Rohan, do you think that the propellants can cut down on the cost of going into space?
Okay, let's do a simple math here. Let's take PSLV for example. Um, or let's go with Falcon 9, the much more famous rocket. Yeah, because of reusability, they've brought down their per kilogram cost to around $10,000 average. Okay, $5,000 also they will fly if yours is a big satellite, but let me keep $10,000 per kilogram. Yeah, and normally satellite, when we talk about satellite, let us just forget nano satellites. Okay, they're just science satellites. They're not for some big use. So a good satellite which can do decent amount of work starts from 100 to 150 kilogram plus. Okay, in that category. So 150 kilograms into $10,000 is the amount you pay for launch. Out of this 150 kilograms, around 70% you require propellant volume per se. So because once in orbit raising, if you want to go to geostationary orbit or maintain yourself by attitude correction at the low Earth orbit where you are put, requires fuel. So sadly, this corresponds to much of the satellite volume. It of course differs on design. So you only have around 5% left for payload, and payload at the end of the day is what gives you return on investment. So electric propulsion, on the other hand, doesn't require so much of propellant to do the same task. So you require 15% when compared to 70%. So you shrink the satellite or you add more payload. So that's how significant propulsion is.
Right. And the company can probably make more profit as well when you have a higher payload capacity.
Exactly.
That is
That's why you
something.
see, true. So on Earth also you see we transitioning from internal combustion engines to electric mobility. So the same things up in space as well.
Right. That's really interesting. That's really interesting. Now, I had this one question that there is a US-based startup called Relativity Space, and which basically 3D prints a rocket, including fuel tanks and even rocket engines, in just around 60 days. So similarly, what new ideas or technologies do Bellatrix and Starlab bring to the field? Sunny?
Okay. Yeah. It's let's
I think
Sunny
Rohan, you
answer
can
this
go on
first.
with this. Yeah.
No.
Rohan,
But I
please
thought
continue.
Okay.
Sunny after you. Yeah.
Okay. Fine. So what we are planning to do is, Naman, the first thing, as I mentioned, when I say very quick access to space, right now, if you talk about the launch vehicles, they like the big factor, the most important factor there is the reliability, and then comes the cost, because you have a very expensive payload, sometimes humans there on the top, right? So reliability is one factor that a lot of people focuses on while selecting a launch vehicle. When it comes to sounding rockets, reliability comes to second. The first is the cost, because our customers are students. Now here the payloads are not so expensive. You have a payload which can be built in 10,000 Indian rupees, 20,000 Indian rupees. So even if you go with you cannot go with a sounding rocket which can cost you something in crores. You can definitely go with if it is in some lakhs, right? So here the main focus that we have got is reducing the cost, and that can happen by increasing the payload capacity that we are having. Now, here this would be very difficult to balance it out because we are using carbon fiber material for our tanks, and which is very expensive. But the additional benefit that we're getting here with the carbon fiber is, first thing, we can reuse it many times at some till some point extent. And the second thing is that means I can have 10 to 12 launches for one rocket. Okay, that's the reusability factor that we have right now. And the second thing is the payload capacity have shifted from 8 kilograms to 25 kilograms. So now we can lift up more weight. So we are right now in sounding rocket, we are not going with any unconventional method of building rockets. We have kept things very simple because our future plans is to do a lot with launch vehicles, and in that we have some plans, but nothing so concrete. The second thing that we are focusing on is having some, satellite platforms already in space, where students don't need to send their hardwares; they can just program it by sitting here on Earth. So for that, we have collaborated with a Canadian company who are sending the satellite next year, and we would be selecting few students from India who would be programming their satellite and performing the experiments out there in space. So these are the two ways. So in sounding rockets, we are working on some a business model which is very rare to be there in this industry right now. And on the other side, we're working on creating some interactive satellite platforms for students so that they don't need to build the whole hardware if they want the orbital experiments to be performed. So that is what is going on here at Star right now.
Right. Regarding the satellite that you talked about that can be coded while it is in the orbit, can you please elaborate a bit more on that?
Definitely. So, as Rohan mentioned, you like if you consider a satellite mission, the first thing comes into mind is how to build the whole hardware, and then you have to create a software for the satellite. Then you have to work on the ground station, or you get it rented, right? And then you have to get permissions. You have to do a lot of certifications work to be done. Now, when all these comes in the mind of students, they take a backstab. They don't, they like there are very few students in India who would actually go with this because they have got support from the universities basically. Now, not all students can do this right now just because they're scared of doing it. So for that, what we have planned to do is we would already have an hardware there in space, right? And that hardware we are not building. It's in collaboration with the company who's already doing it, and students would be able to program it. Now they can get the satellite rented per orbits. So they like if you want 10 orbital periods, then you can get it rented for 10 orbital periods, right? And then your code would work there. So that is how it works. It would have some payloads, very basic payloads. I'm not talking with the extreme or difficult or complicated spectrometers or such. Very basic payloads through which students can start with.
Right. In the same analogy of Ola and Uber, this sounds something like Ola Share. You know?
Yep.
Yeah, Rohan.
Sunny, good to know this part which is not available in public. Congratulations and looking forward for your success.
Thank you.
Coming back to your question, Naman, we specialize in, as you know, propulsion systems, but where we differ is we have built one of the world's smallest thruster. We call it as the Nano Thruster. It's smaller than your small fingernail. So satellites come in different shapes and sizes, right? So something we figured out is every satellite has unique requirements of its own, the class of satellites. So one solution fits for all will not work as others tend to do. So we have a dedicated solution for each class of satellites. For nano satellites up to 20 kilograms, we have a dedicated propulsion system. Similarly to 100, 1,000, 5,000. So we do engines even as satellites weighing more than 5-6 tons, right? So that's our capability. We have put up one of the Asia's largest privately funded space propulsion labs at IISc here in Bangalore, at our lab, where all space can be simulated and tested. Again, unique ISPs. We also work in the chemical propellant area where we develop something green propellant, an alternative to hydrazine, which is a much more common rocket fuel. And electric, we pioneered basically using water as a propellant and ionizing the water. So we don't split hydrogen and oxygen as people would confuse. And then combust, that becomes chemical propulsion itself, electricity aided chemical propulsion, but it's pakka electric. So what we do, we bombard it with microwaves, split the atoms, rip out the electrons, and then you have a plasma, and then you push it out at higher velocities. So that's where we specialize.
Really interesting, Rohan. And congratulations on all the feats that the company has already achieved. And
Thank you.
there's a long way to go still. Uh, I think an interesting fact here is that both Bellatrix and Starlab were founded in 2015. That is, they both have covered a 6 year journey. So, how has your journey been all these years, and how long we are expected to wait before your first major milestone? Rohan,
I
would you
think
like to
Rohan
go?
should go with this.
Sunny, you started in 2015, so I didn't know that.
He started as a club in 2015, not as a company
Yeah.
then. And I think there was a minor correction here.
Don't know. Anyway, that's good to know because I only keep saying there were two startups, Astrum, Bellatrix. Now, in my talks, let me add you as well. That's good to know. The journey has not been smooth. Basically, see, I call this different era. Okay, just like BC and AD. So, if you were a startup in India before 2014, okay, you wouldn't be successful because the investor, be it the investor ecosystem or the public perception or the government organizations, didn't see a need. So, and that's when Elon Musk was not a common household name, right? And you didn't see this investment happening in space. 2015 to 2018 was the period for us to struggle to set and evolve the tech, raise funding, and be heard. So that it took a time. So post 2018, what happened is um, India becoming signatories to MTCR, the Missile Technology Control Regime, and the Wassenaar Pact, Australia group. So it allows you to collaborate on so-called dual-use technologies, which has defense use as well with countries such as US or other NATO countries. So this kind of opened up the entire ecosystem from the government side. And of course, the private space policy bill, which government is in talks to privatize the industry, also made headlines. And then we were the first ones to raise a VC-focused private investment in India, and that's when it all started. So it's easy for startups now to come and actually raise capital in India as the industry is picking up. So yeah, till 2018 end, it was kind of a struggle, but we did focus on developing tech. And then it was kind of a quick development. Right now that the capital is there, you accelerate your development, increase your team. So that's how the time for us was. So 6 years is a good journey, but it is getting excited now, is what I would say.
Right. And if I can ask you, how big was your team when you started out, and how big is it now?
So me and my co-founder Yashas, he's from Mysore. He's a family friend. He looks into the non-technical aspects of the company. I look into the technical aspects, and my two juniors from college, basically, who are like very good at math and designing. So it was the four of us who started it, and now we are a team of 50 plus presently.
That is wonderful. That is wonderful to see how it grows in just 6 years, being a startup with nothing in hand when you just started out.
Oh, we are a small team. There are other startups which have crossed the 100 team member mark. We should big claps to them as well.
And a shout out to all the math lovers as well. You sure have a future.
Math is
Yeah,
so important in space.
Very true.
definitely. Sunny?
Yeah. So, like, first of all, what can be more inspiring than, having a startup in our country which got started with four-member that have raised VC funding when there was not much investment going on in the country in this industry. I think hats off to you, Rohan. You really pulled it off, and I think this is going to inspire a lot of generations in future as well. And you're talking about Star. In 2015, we started this as a rocket club in a college campus with an intention to build model rockets to launch them. Because I live in Gujarat, and Gujarat, no one talks about aerospace, no one talks about rockets. They talk
All
about
diamonds.
business. Yeah, they do talk about business and food, but they don't often talk about rockets. So my intention was to build an atmosphere in my campus where people talk about rockets, and I started with model rockets. So that would be the easiest thing one can start with. Uh, so from 2015 to 2017, we were incubated in my campus itself, and it was a one small room given to us where we set up. I still remember we collected all our basic electronic components that we had created. We built CAN sets, satellite prototypes. We created Mars rover, a mobility system based prototype. That is how we gained a lot of experience. And uh, in 2017, we realized that like in India, we don't have that culture of space education. In fact, in world right now, if you see, we have universities, but then what about the project-based learning experience where students are given problem statements and they come up with their engineering solutions on their own? That was something which was missing. And that is what we introduced. That is a project-based learning experience. That is, if a kid asks me what is a rocket, I won't give him the direct answer. We would ask him to perform an experiment under our guidance, and they would get to know the answer on their own, and they can define rocket in their way. That is one thing that we wanted to have. In 2018, we shifted got our own working space here, so we started two laboratories. It's bootstrap, like we have not gone for the investment till date. We started with a 0 rupee venture. The another thing I wanted to show the students that in order to have a startup, the first step should be the problem, then it should be your solution for it, rather than just finding out the investors. Because I've seen a lot of students, what they do, they get ideas, but just if they don't get investment, they stop themselves. So that is one intention we had at the initial day, that we would go for the investment at that point. Then in 2019, we got rejected by three incubators in the in the country, and they were at different universities. And then pandemic happened, and it turned out to be blessings in disguise for us, where we would the ad tech platforms, they how they started performing. That is what happened with us as well. Suddenly, we started getting more and more students, and even our research and development got that push that we wanted. And then Kalam, we announced it just 3 months back. We already have cleared our preliminary design review now successfully. One more thing, Naman, this is one of my favorite questions, because in a startup journey, if you don't get challenges, if you don't feel like every day is you're getting that learning experience, you're you're facing some troubles, I think then something is wrong with that startup. Either they are not innovating, and even that is what we feel. If we feel that everything is going so smooth, that means everything's stagnant here. So challenges and the problems that we face makes the journey more interesting. And I think 6 years, on this 5th November, we are going to complete 6th year of operation, and just looking forward to having like launches in space now very soon.
Yeah, I mean, everyone would second that if you're not growing, you're definitely not facing any challenges, and if you're growing, then definitely you will be facing some challenges. That is a part of growth, and that is probably how we grow. Right?
Yeah.
So Rohan, Bellatrix had earlier won an order from ISRO for developing the world's first commercial microwave plasma thruster that you already touched upon, which uses water as its fuel. And this is one thing where if you say it out to any Indian that we're using water as a fuel, or just to anyone in the world itself, then it will get them excited, because if you can use water as a fuel, then you're probably using the most efficient or the easiest occupiable substance as a fuel to something that is so crucial and so important. So, how efficient and how feasible is water actually as a fuel, and does water have the potential to replace other fuels?
I have to answer your question in two ways, right? See, electric propulsion is slow in orbit, unlike chemical. Chemical propulsion is where you take the energy contained within the chemical bonds or the atoms, right? So you get a lot of energy very quickly. Okay, but with electric, that's not the case. The thrust, we call it just millinewtons, whereas chemical thrust starts with newtons and goes to kilonewtons, right? So if you want to quickly go, that's the thing. But with water, of course, all the cryogenic rockets is basically water. They're just splitting the oxygen and hydrogen at the end of the day and using it. With electric in space, the advantage is, see, there's no atmosphere, so there's no drag, right? And Newton's laws still work. So constant acceleration over a period of time leads to increase in delta. So if both of us sit on two different rockets, one powered with chemical and electric, say Sunny flies chemical, I fly electric, within few seconds I can't see him, he's just off. But as soon as his propellant burns out, he continues to be only in that speed. Okay, whereas me, on the other hand, I continuously, even though I start slow, but my engine never stops. I continuously accelerate. Okay, so I reach a point where I surpass Sunny in terms of speed, and my speed just keeps adding. So the corners of the solar system definitely seems accessible through this. So only the initial starting speed is slow. So that's the advantage with electric per se. And with water, not super advantageous when you compare it with some heavy molecules like xenon and all, because it is easy to ionize a monoatomic gas than a complex atomic structure like water. Okay, but the advantage what water has is there's a term which you guys are aware called in situ resource utilization, meaning there is water on moon, there's on Mars, there's water on Jupiter's moon, which is that Europa. There's water on Saturn's moon, Enceladus. So what happens is you don't carry your return fuel back. So you get to carry more payload. So that's the advantage. If you want to send the big spaceships as you see in movies, right? The Martian, for example, you need electric for that because you get to carry more payload and more stuff than actually carrying your return payload, return propellant back to Earth, which actually you can get on other planets. So that's the advantage with water has, and that's what actually forced us to unravel its mysteries. It was not a smooth journey, but we cracked it though. But yeah, that's the advantage with water has.
Right. So basically, it is efficient enough to have humans travel from Earth to anywhere in the solar system at least.
So the term we use is specific impulse. That's the mileage. Basic term is, if you convert specific impulse into understandable language, it's the mileage per kilogram of how much thrust is produced per kilogram of fuel is burnt, right? So unit is in seconds. So for electric, it's always very high. Chemical cryogenic engines, if you see, they have around, the best ones have around 464 seconds of specific impulse, the RL10 engine. But when you look at electric, the worst performing one starts at 900 seconds. The best ones go up to around 5,000 seconds of specific impulse. So you don't need much propellant to do the job. So water falls in the sweet spot of around 900 to 1,500 seconds based on power available. Right. So you get to do more with less.
That's wonderful. And also, Starlab has developed Makerspace to train young students. It consists of rocket assembly and test area, satellite simulation platform, and lunar soil simulant. Could you please tell us the process of developing this simulations, and specifically the lunar soil simulation, because that is something very fascinating.
Right now, like we have created that, the rocket assembly and the test beds for the high-powered rockets. Right now, we're working on creating the similar for hybrid rockets as well. Uh, like it's a whole space where students can come if and our team can help them in designing the high-powered rockets, and then we help them in getting it manufactured as well. Selling rocket motors in our country is not legal, so what we do is we don't provide them, we don't sell it to them. But what we can do is, based on their criteria, requirements, what we help them in manufacturing motors as well, and then we help them in launching it from the remote location. For satellites, we have stopped our operations in the domain of satellites. Now we used to do it till 2018, where we used to have them in building the ADCS systems and even the basic flight computers and the communication systems for the CubeSats. We are right now planning for the lunar regolith simulations as well. Yeah, because in last, after the especially after the Vikram landing and the Perseverance landing, we have seen that a lot of students are now interested in rover missions, and we have seen a lot of students team participating in the international competitions as well. So we are planning to have some test beds for them where they can even test their deployments of the suspension systems. They can test the they can actually figure out the actual landing of a lander on Moon or Mars, where we are also planning to simulate their gravity using helium balloon as well. So those things are still in the pipeline. But now, just because of pandemic, we are not focusing towards developing those test beds because even students won't be able to come here. So our main focus is towards developing Kalam as soon as possible, and just getting in contact with ISRO and getting it launched in 2023.
Right. Can you elaborate a little on Kalam specifically?
Definitely. So it's a hybrid sounding rocket. So we are using nitrous oxide and paraffin wax as a fuel. And it's a laughing gas, but it's making a lot of people cry because not much work have been done on hybrids so far, especially in our country. So we're working on that rocket, which would have the payload capacity of something around 25 kilograms. In 25 kilograms, the 20 is for the commercial, where even startups like satellite companies who want to test their electronics or some exotic materials which are like 4D printing material, then they can launch it in space and get a simulation done there. And we would have some 2 to 3 kilograms reserved for schools, and then 1 or 2 kilograms for some NGOs, because in last one year we have collaborated with few NGOs, and we have seen that the students, they are very keen in learning science, and they really want to perform a lot of experiments, and they have already performed there on ground. But looking at their talent, their skills, and their interest, we feel that they have that capability of designing an experiment which can go in space. And that is why we have announced our first mission named Wings of Fire, that is taking dreams to space, where we will be having some students experiments and experiments designed by few NGOs going to space in 2023.
Right. While you're focusing on student-based satellite students, the satellites which are essentially made by students of some university, colleges, institutes. So I would like to put it out that College of Engineering Pune, COEP, in 2016, they launched, they made a satellite called Swayam, which
Yeah.
is now in orbit. It was launched with the help of ISRO, and now they're building another satellite. So I'm sure they'll be one of your customers.
Amazing. I think, SWAYAM said and SRM said there are few satellites which are developed by universities, and I think they set an example for other universities as well, that they should have such initiatives of of giving an experience to students about the space missions, and that is the only way we can get more and more startups. Because right now, if you see, if India is a, and geographically as well, India is one of the best places to launch rockets from, right? So
Right.
we need more rocket startups in India who can serve the customers globally.
Okay, great. So while we're talking about space technology-based startups particularly, it would be very mean of me to not talk about SpaceX. So the giant leading this industry as of now, at least, their initiative of Starlink satellites has been in a lot of debate these days. And being an astronomer myself, such businesses concern the availability of open skies and its effect on ground-based telescopes. So what is your take on this? And do you too think of venturing out in such a business? Well, it's a great idea, of course, no doubt, a profit-making idea, but uh, yeah, Rohan?
Yeah, but let's see, to answer your question, of course, it has got all the astronomers thinking, what are we up to? What are we going to do? So there are big projects like the 30-meter telescope. So there are bigger projects coming up, where you can peek, farther into the known universe. But when you have mega constellations. I mean, every now and then you would see these streaks. Filtering them out is, of course, no good news for astronomy. But of course, a software can handle that. It's known to kind of, cancel out the satellites if orbital paths are known. The TLEs, as we call, if they're known, you can actually cancel them out. So it's good. It's still not such a bad news for optical astronomy, but it is definitely a bad news for radio astronomy, because you'll get a lot of noise and you need to cancel out that frequency. If you cancel out that particular frequency, which, for example, what at Starlink works at maybe 40 gigahertz, that band, that particular band, you cancel out hearing that frequency from the universe. So, gamma ray bursts are all high frequency bursts. So you need to, so that's sad news. But again, there's always a solution, right? So for humanity to grow, we can't be Sheldon Cooper. So even if you see the Big Bang Theory, even he also changed in the end, right? He didn't like change before, but then he embraced change. So similarly, to ensure that even our life on Earth is not affected, we have to look at the problem the other way. Why not use Moon as a base for all scientific experiments? So what Sunny is doing at Star, or what we are doing, will definitely enable much cost-effective access to space, which SpaceX has already proven. So utilize Lagrange points around Moon, or the surface of Moon itself, or the backside of the Moon, to do both radio and observational astronomy, which you can do it much better because there's no atmosphere. So I think a younger generation has to plan that. So that would be an answer as far as astronomy is concerned.
Yeah, I think the major problem with satellite-based astronomy has been that its cost, because it costs a lot more than what it would cost to build something on Earth. And with Bellatrix and Star Labs and many more startups, I think that is where we exactly target the cost of sending satellites into orbit. So
Yeah,
yeah,
so you see, cost is a major part of it. So these days, even electronics are improving, right? So and then MEMS-based technology. So even commercially off-the-shelf components can withstand a radiation load of up to 20 kilorad. Mill grade ones up to 100. Space grade rad hardened, they go much higher. But when commercial tech is developing so rapidly, so there will come a point where to do telescopes or satellites in space will be much cheaper than setting them on ground. That drive is definitely possible.
right. That sounds exciting. Sunny?
I think very rightly said by Rohan, and I completely agree with this point. And it's definitely even a problem for amateur, you know, astronomers. But the thing is, see, like in pandemic, this is what we have seen. Like not most of us were used to cooking, right? And most of us have cooked for the very first time in our life. And when we do it, we create a lot of mess on the kitchen. But then if we keep doing it, keep practicing, we then like, stop creating that much mess on the kitchen, right? On the platform. And that is what with have happened with the space exploration. If you see, we have created a lot of debris out there. Now, that's one of the disadvantages. But the thing is, we cannot stop exploring things. We cannot just stop pushing the limits in the terms of building technology. We have to come up with more solutions for it, and that is what I think Rohan mentioned. That why not to have our telescopes on Moon? Why can't we have our telescopes there in outer orbits, which can look into deep space? And I think there can be some solutions where there can be some satellites there, and that would science fictitious, by the way. But the thing is, there can be satellite in the outer orbits looking at the deep space, and people here wearing VR glasses and would be able to look what the satellite is looking right now. That's just an idea which came in my mind, right? It's a raw idea, right? So think there are a lot of things which are possible, and I think this mega constellation is a problem. Someone would come up with an engineering solutions of it as well, so you can reduce the number of satellites and still get that bandwidth and that range, right? So there, I think people should stop comparing and start finding out the solution, and that way they can also get a lot of business done.
Right. Now that you touched upon space debris, and because both of you are venturing out in business where you have to do a lot with satellites and launching satellites, more and more satellites at cheaper costs. So, what is your opinion on space debris, and how big a problem do you think it is?
Sunny?
So the thing is, space is big, like and but the number of launches, if you see nowadays, especially by US, it's increasing, and that is what is creating a lot of junk out there. Now, I think I've seen like that there are a lot of framework which are now being changed and they are modified, where companies are moving towards reusability, and even you would find a lot of deorbiting mechanisms used in low Earth orbit based satellites as well, right? So if you talk about the policies, they are also moving towards and now focusing towards reducing like the debris there. That I don't mean like removing the debris which is already there, but dropping down the number of debris that we would create in future. And that is what also we are focusing towards, and that is what we always say, that we really want to see send humans to Mars, but that doesn't mean we don't want to take care of our planet, right? So that with that intention only, for Kalam rocket, we have taken this initiative of not going with any deployable mechanisms in space and getting the whole rocket back safely here on Earth. And that is why we selected N2O and paraffin vexor as well as a propellant. Um, Talking about the launch vehicles that we are focusing to build, one of them is Phoenix. With Phoenix, we're still figuring out, how can, like SSLVs, if you go with the, retro propulsion based systems, they are super expensive. You cannot go with that right now. So we're still figuring out the recovery techniques for the same, so that we create the least debris there. But I think this industry have a good opportunity for startups, who can figure out what to do with the debris which is already there.
Right, Rowan?
Yeah, so this is an important question. But to start with, we have to be responsible companies, right? Not just aim for the profit point of view. And space debris is a nightmare. When so many thousands of satellites you're talking about, even a small debris as big as I think 1 centimeter cross 1 centimeter junk traveling at around 27,000 kilometers per hour hits you. It's a bad kinetic injury. So there are startups coming up, or companies, or academic institutions, research organizations like even ISRO, ESA, NASA coming up with ways to mitigate space debris. But still, the number of satellites going up is also increasing. So FCC, the US regulatory agency, has made it mandatory that every satellite should carry propulsion systems and should have sufficient propellant so that at the end of life, they deorbit and
Okay.
create and so you orbital space will become like a real estate pretty quickly. So you have to ensure that you don't remain there as debris. You have to ensure that you come down. Similarly, rocket companies, the upper stage always tends to remain in orbit, the final stage which injects the satellite. So even there, things are being made to ensure that you put it on an elliptical orbit where the perigee is close as possible, so that the drag of the Earth's atmosphere takes you inside. So that's what, as I said, we have to be responsible, and it's a major threat when we talk about the number of satellites going up. So one, it requires propulsion, and two, let's be responsible.
Right. That's a really good message from Rohan. And my next question, actually, Rohan touched upon it, but in a more general way, that the investment for startups have increased in India past 2014. But particularly for space technology, space startups, if we go 3, 4 years back, probably we didn't know about a lot of these startups. And we've never even heard of a startup who's working into a private company, working into space-based technologies. And but now we sure do. In the last few years, there has been a boom in this industry, and there are many names that now come out. Uh, from this particular space. So, what are the major reasons for this boom, uh, particularly for space technology?
Rohan,
So
I think.
Naman, I'll keep it short, considering keeping time in mind. See, the first thing is the investor community or the people who invest money have really understood the value creation which space can bring, right? So, or even the word software was coined for the Apollo lunar landing. Till then, even the first code was written for that. So the spin-off technologies. So what if you do something for space? There are so many spin-offs which come out which will be used on ground, right? So that is something which they have the investor community has understood. And of course, other than the regulatory aspects is a major hurdle that being cleared. And one more thing, it's also easier for startups. Let's say space, you have to divide industry in two segments, the upstream and the downstream segment. So we belong to the upstream category where we build hardware which works in space. The downstream guys are the ones who use the data which is created by upstream and give you a good understanding of it, like image processing or something like data intelligence from space. So it's easy for downstream companies in India at present to raise money more quickly than the upstream ones because the investor sees a quick return of investment. Upstream, you develop tech, so the gestation period is pretty high for you to do that. So I think we should reach where US is right now, where both upstream and downstream are valued equally, and it's kind of easy to raise. But nonetheless, it's a good start in India at present. So the companies which are coming, it's very competitive out there. What's more important is as Sunny mentioned before, identifying a unique problem and coming up with a unique solution is more important than just to copy what others are doing. If you copy, you will not survive for long. So that's, I think, we Indians are good at jugaad, they say, but um, let's ensure. I take this message from Sunny is that you should have a unique problem and a unique solution. If not, you can't survive in space industry in India.
Right. Sunny?
Yeah, so I think, to be very honest, I've learned a lot from Bellatrix, Skyroot, and Agnikul because I've been following them since years. And uh, one thing I've seen is, in India, we have got a very strong ecosystem. I see them representing India globally, in the conferences and talking about space. And now people are looking at India, not only Indian investors, but I can see the foreign investors. Like in last 3 months, we have done few meetings with foreign investors, and we've seen this that they're really looking towards India now. Few years back when in 2015 and 16, it's not that we didn't have startups here in India, but startups, like most of the people who were having ideas around space, they were just confused about business model, including us. See, investors are really interested in your business model, right? They want return on investment, and they really want to see whether your business model can survive 5 years, 7 years, 10 years, and how quickly you can bring change in your business model. Um, and that is what started happening in 2017 and 18. And then we know that ISRO announced in space, which actually gave a very strong confidence to all the investors in India. Now they knew that in now, like, any startup would need mentor, right? And when ISRO announced that they would handhold startups and provide them all the guidance that is needed, so investors got that confidence that even if a young team gets stuck, there are people to handhold them, right? And if you see all the founders of these companies, or all the space startups that we have in India, they are very young, right? But we have got someone backing us, that is the people from ISRO having very strong experience. So we have a very good mixture now. We have young people with some unconventional ideas, some different business models than other countries, and on the other side, we have experience which is helping us in building all these stuffs, right? And on that, now in this ecosystem, investors have entered. You have ideas, you have got the mentors, and you have investors. That's an ecosystem that India was looking forward for having in 2015, but now we have it in 2020. So I think India, have a very strong future in this domain. And not only this domain, I've seen this happening in quantum computing as well now. So it's also growing.
Right. So basically the ecosystem, this ecosystem has become, the fundamentals of the ecosystem have become so strong that you can only grow from this point. That is really good. And since we are a little out of time, I think this should be my last question towards you. And there are many space enthusiasts currently watching this talk through YouTube live, and for their benefit, do Starlab and Bellatrix have any upcoming opportunities for which they can apply and probably get a chance to work with your enthusiastic team? Rohan?
Sunny. I'll start with Sunny, who's the student guy.
Okay, fine, thanks. So do have training and internship opportunities almost in every month going on, right? Where we serve students with problem statements and they come up with their engineering solutions. Also, we have collaborated with the space startups, where what we do is we get requirements from them and then we directly connect students with them so that they can work with those startups, get to know how companies did work, and they can build their career into this industry. Along with that, obviously, like very soon we would be launching the applications for Kalam, where students would be able to submit their ideas. We would be screening them with the help of ISRO scientists, and the selected payloads will be going to space. So just keep an eye on whatever activities we are doing. With there is a lot coming from our side, and just wishing you all the best for your future.
Rohan?
So sadly, Bellatrix doesn't offer internships for students. We are still working out on that model. But what we are open is to collaborate maybe with people like Sunny, where if they identify the right talent which we need, so that student definitely has an opportunity to work with us, be one of the scientists in our team. So that is an opportunity which is open, and we don't look at grades per se, as long as the basics are right? Don't forget the basics. So the basics are very important. But yeah, so opportunities are there, but uh, for example, if I would like to work with Sunny maybe after this. So yeah, if people like them point out a few students to work with us, definitely, or even you from your university, if you find a student who is fit, you can please forward their CVs. We will consider them directly for training and job.
Right. That is great.
Thank you so
So
much, Vivek.
everyone watching this should keep an eye on the Bellatrix and Starlab space, right? On their websites and all their social handles to know how you can contribute to these startups and be a part of it in this growth journey. So I think with this we have come to an end of this amazing session. I'm sure this talk would have helped everyone gain a deeper understanding of what exactly Star Labs and Bellatrix are, what their goals, and how they are going to be an essential block of the Indian private space tech industry. Thank you, Rohan, and thank you, Sunny, for giving me this opportunity to have such an interesting talk with both of you. I'll hand over to Prathamesh.
Thanks to you for the
Yes.
wonderful opportunity.
Yes. Thank
Thank you,
you
Naman.
all.
It was
Thank you.
very good.
Yes.
Thank you, Rohan.
Thank you everyone to join, and thank you so much for this wonderful session. And now literally I am confused whether this was an entrepreneurship lecture, whether this was on science and technology, whether this was a motivational talk. Really, really very mesmerizing, very rejuvenating, very, very thankful. Yeah. So a formal thank you. I would like to extend my thanks, sincere thanks to our professor B.B. Ahuja, the Director of College of Engineering, Pune; Dr. M.S. Sutavne, the Deputy Director of College of Engineering, Pune; Dr. P.R. Dhamangavkar, the Associate Dean Student Affairs; and lastly, Dr. Mrs. Aarti Petkar, the Faculty Advisor for MindSpark, for their constant support and guidance. And finally, the thank you to our very own Mr. Naman Bajaj for joining this session and making this chat so lively. And lastly, to the two guests whom we were able to witness, and they were able to get time out of their busy schedule for us. Really, really very thankful to all of you.
Thank you so much. Once again, convey our regards to your faculty members. And thanks to Naman for not just keeping the question related to entrepreneurship, but he did a good job in, circumventing every orbit, I would say,
Yes.
and asking different things. And it was a pleasure to meet you, Sunny, virtually. And thanks to everyone watching live.
Same here, Rohan. It was nice meeting you, and thanks and great work organizers.